As far as running a sample cup, and these are disposable. Have a lid. The lid is for temporary storage only.
Yep.
It's not sealed. If you want to seal it in there, you got to put some parafilm around it, but for temporary storage, it works good. These are meant to be disposable. So you use it once, throw it away, and then you can get more of these stands from us. Once there's samples in there, you just basically need to cover the bottom of the cup. As a general rule, you don't want to overfill, you don't want to go over the top because it can dirty up the chamber. Place it in there. This closes down, and then you just push that down to close it. Then you lift it back up to release it. With it closed, it's already basically taking a water activity test as soon as the sample's in there. The sensor will update real time, anytime, no matter what's in there. So it's reading 0.34 right now because that's room humidity. So if I open it up, and I leave it there, it will just read room humidity. The temperature is coming from us. This sensor right here is measuring the temperature with infrared. So you'll see as it closes down, it's going to change a little bit based on whatever that cup is reading. It's set right now to control to 25 degrees C. You can change that temperature right here on the main menu. So you'll see several different choices here. One of those is chamber settings. So here's temperature control set to 25, but I could change it to 22. Hit enter, and now it's controlling to 22.
How much does temperature have impact on the load?
So it impacts it about, and it's specific for every kind of matrix. But basically, for every degree, you get about a 0.002 change in water activity.
Okay.
So this is set so that it won't give a reading until it's within plus or minus 1.1 of 25, or whatever you've set the temperature to. The stable mode is referring to how it determines whether or not the test is finished. So water activity is an equilibrium test, so it's trying to find vapor equilibrium or lack of change over time. And this stable mode dictates what that setting is. So it's looking for a difference of 0.001 or less. And when you put it to slow, it wants to see that difference for 6 minutes. So if within a 6 minute span it ever sees a difference that's greater than 0.001, it starts back counting until it gets 6 minutes of never having a difference bigger than that. So the more stringent you set that, the longer the test will take. But the more you're assured of having true vapor equilibrium. So there's a trade-off, obviously. Average, so slow is 6 minutes, average is 4 minutes, fast is 2 minutes for that. And so obviously as you go down to fast, it's going to give you a result faster. There's also this quick mode, which will give you a result after 10 minutes no matter what. But for your purposes, you're never going to want to use quick. In fact, I would suggest you use average. But if you're seeing that on average you're not getting full vapor equilibrium, then you'd want to change it over to slow.
If it's not at an equilibrium, it will indicate that on...
It does. So on the main screen here of where you're taking a test, whoops. So if I go back to the test screen, you'll see this graph here. And that graph is going to track whatever the result is. And so you'll see right from the graph whether or not you've achieved vapor equilibrium. Because if the graph's still going up, trending up, then you're not at equilibrium. And if you have it set, for instance, at fast, it will run until it meets the requirements of fast, and it will put a sign there that says stable or stability. If you don't open the machine, though, it will just keep tracking the water activity. So if you were to, it will beep at you and say it's met its requirements. But if you don't open it immediately, it'll just keep tracking, and you'll be able to see whether or not it continues up, or if average is an okay setting. Mm-hmm. So a great thing to do is just the first time you run it, if you really want to try and optimize, you can run it with the fast mode, but then let it keep going after it finishes for maybe up to 40 minutes and see what kind of difference you achieve. If it's small, then there's no reason not to run on fast.
Yes. Okay.
Some of the other things you can change here, like the graph parameters. If you want to look at relative humidity instead of water activity, you can do that. And then here's where you do sensor calibration if you want to do a calibration, or if you want to clear the calibration points that you've done. Those are all from this screen. You can also set up the system to do a verification. So verification and calibration, of course, are two different things. So verification is, did it meet the required accuracy? And you can set that tolerance level at any level that you want. The accuracy of the instrument is 003, but if you're accepted, if 005 is fine with you, then you set your tolerance at 005. And then it will, so if I set this in here at 003, oops. Sorry, I'm forgetting the decimal place. Okay, so with that set, there's a couple ways that I can check these standards. I can put it in there and just run it with the same settings I'm running all my samples, and then determine if the value is within plus or minus 003, or the tolerance of what's reported on here. So you'll see on the side of here it says 84. So that's the 0.84 standard. That only gives you 2 digits. If you want to see what it is into the third digit, in your paper goods here, one of these has your certificates for all your standards. And here it will tell you what the tolerance is. So this is in percent RH, but if you just move 2 decimals, it's 0.113 plus or minus 0.003. And you have that for each one of your standards in here. So that gives you the true value of it.
And for recording purposes, how long do the standards last?
They should be good for up to 3 years, as long as you take care of them, which means, and that the main thing is not to leave them out like I am with this one right now, because I took it out of here. But it should go back in here and get sealed up. And as long as you keep them in these plastic containers and then shut them tight, then they should be good. The reason why you don't want to leave them out is because they'll change to match room humidity.
I see.
Would it be better if you put it in like a desiccator?
No, that'll dry them out. If you put it in with desiccant, but if you put it in a sealed container, but you'd have which is what this is.
Yeah.
Yep.
And that's good, just at room temperature. You don't have to put it in a refrigerator.
No.
Nothing like that.
Yeah, no. Keep them at room temperature. So anyway, back to the idea of doing this verification. So you could put it in and just run it. You can also bring the standard and put it right on here, and it will automatically detect which one it is.
Oh wow.
Oh,
And if you hit verify, it will run it, and then based on what I set that tolerance value, it will check against that, and if it meets it, it'll just come up and say you're good. So you can do that. So then I would put it in here, and I'd hit verify and OK, and now it's going to run. And when it's done, it's going to come up and say it's good, it's within, you don't need to do anything, or it's going to say it's reading out of tolerance.
I see.
And at that point, you'll need
can
new
calibrate
standard.
it.
You calibrate it. Oh,
Yep.
okay.
Yep. So then it will give you the option, do you want to proceed with the calibration? And if you say OK, then it will go through and read it again, and then make an offset adjustment for whatever it needs to get the right value.
I see.
And you
Okay.
can do that with any of the standards.
But it's making the assumption that the standard is
Good.
Good.
Yes.
But
How do you tell us now?
how do you ultimately determine if it's good?
If the standards, one of the things is appearance. So these standards should look like slurries. So if they're, sorry. So one thing is if that starts to harden up, and so there's no liquid in there, that's an indication that they've gone bad.
Okay.
Or if you just can't get the things to calibrate, so you read one standard and it reads fine and another fine and then one just won't read then that's an indication that that standard's probably gone bad. And you can buy additional standards from us.
I see. Okay.
But again, about up 3 years, it should be good.
Okay.
The unit itself, does it need any calibration or preventive maintenance from you guys?
Yearly.
Yearly.
We recommend, and then with that, you get a new certificate that says that it met calibration requirements. There's an option for us to come on site and do that, or there's an option to send it to us. And obviously, the on site's a little more expensive.
Sure.
Yep.
What else was I going to say? So, okay, you've done the calibration. You're
Yep.
ready to run the sample.
Yep.
Okay, so at that point, it's basically the same as the standard. I mean,
Yeah, it's
but
just-
you have an unknown. You put there.
Put that in.
Do you? Is it better to have a smaller amount of sample, just enough to cover the bottom, and not too much?
Yeah, it'll
because
slow it
take
down. Yep.
It'll slow down. the
Yeah.
process.
And there's trade-offs for both because you're also making a smaller volume. The biggest thing though is to try and make sure you maximize surface area for the sample. So like if it's a solid dosage tablet, for instance, you'd want to crush that so that you're breaking it and increasing surface area, and that'll speed up your vapor equilibrium.
Okay.
And I did write down here I'll give you these results because these are the readings that I got, but I also wrote down the different potential filters that you will need for each of these products
Okay.
that I saw in there.
Based on
Yep.
okay.
Yeah,
Okay.
so
All right.
you'll probably want, I mean, the essential oils is the only one that needs this VALC filter.
Mm-hmm.
And if you don't really do a lot of those, or if you don't have really methanol, then you may not need to have that one. You could get away with just the 21 and the Redox.
I see. Okay.
So anyway, that's there for you.
And those are readily available.
Mhm.
Okay.
Yeah, you can buy them in packs too if you want more than one. They will saturate eventually, and you can wash them out and kind of reconstitute them, but you can also just buy new ones.
Sure.
Now, when you put the filter in, you don't necessarily want to just run with the filter. You can run, you could put the Redox in and read everything with that except for these ones that need the 21. All your other ones could read fine with that, but having the filter in does extend the test a little bit because it has to move through the filter.
Okay.
So it's not necessary that you always want to have the filter in there.
Can you show where the filter
Mhm.
goes to?
So the filter's going to sit right in here, and you have a little tool. Whoops, it's this one. And it just lifts that out. Now the sensor sits right there. It sits kind of inside of there. So you would put your filter is going to go right in there. So it sits behind this wire mesh, and then you'll put it on with that on there, and then just slide that off, and then the filter's in place.
Okay.
And you'll be able to see the filter once it's there. So taking it out, isn't a huge deal just to take that and put the filter out, and it will speed up your tests. So for things, most of the stuff that you guys run, you're probably not going to need a filter. It's only if they fall into the categories of alcohols, phenols, chlorides, or acids.
Okay.
And then your audit trail is right there, so you can access that anytime. It keeps track of everything that's been done with the instrument.
Mm-hmm.
So you can always go back and look at any reading that you had. It'll be in here. You can also take this data off. You can hook it up to a printer. You can hook it up to a computer, and with software, you use the software to gather it. You can put it into a LIMS system, and it also has an SD card right here on the side, and you can download the data to that SD card and take that.
Okay.
And it stores up to 10,000 readings, so every reading that you take will be stored on there.
And it's date and time.
Yep, and a date and time stamp. And it will, anytime that you change the calibration, it will keep track there. So its purpose is to meet CFR Part 11 compliance requirements. And there's some system settings. You can adjust the date and time format, the units, how much it beeps at you. Maintenance here, you can export your audit trail. You can configure it, how you're going to export, your display settings, and if the system needs to be updated and we would send one to you, you can use that to do the system update. And then if you want to connect it to a computer, it will tell you how to do that in the instructions because you do have to tell it how you're going to hook up to it
I see.
so that it puts the data out in the right format. And this is just display. You can do a normal or with the graph. There's your print protocol if you want to hook it up to a printer. And I think you can actually go in and give it a name if you want, so you can annotate it after the fact, or you can do sample numbers if you want to just have it count up every time. You can set that to whatever number you want. That's not what I want. And then here's where you would export log to the SD card, and then you can delete the log of data if you wanted to. So most times you'll be on this screen, and like I say, it's constantly keeping track of whatever's going on. And then you would come in, you're going to read your sample, put it in, close the lid, hit start, and then you can walk away. And it'll beep, like I say, when it's done. So if you should be able to hear it if you're in close proximity. But even if it does, and you aren't here, you come back, it'll show that the reading that it got based on the stability setting down here, and then this one will still be updating real time.
Mm-hmm.
I see. Okay.
So if you ran a test and went away for 50 minutes and came back, you're going to get your value that was off the stable indicator, but you'll also be able to see immediately whether or not that was true vapor equilibrium.
I see. And so that's valid data. So, I mean, if you're not sure, you can leave it at the present setting and just let it go and, like say, just check it. And if it's a flat line, then you know that you've reached the
That you're good.
the point you're good.
Right.
to go.
If you're seeing a big, an additional big change, like say you put it on fast, and you ran it, and then it kept going, and it was 0.1 different by the time it went 20 minutes versus what you got on fast, then that's an indication you probably need to move to average or slow in order to get that.
Why don't you just leave it on fast all the time?
Well,
and then just walk away, come back.
Good.
40 minutes. It doesn't change the accuracy of it.
No.
Does it?
No. It would only, the only way it changes is if you actually take the value off of fast that's not the right value.
Okay.
So, in that sense, it is the same as long as you keep it closed. But if somebody's running on fast, it beeps, they record the value and lift it up and run the next one, you don't know whether or not it actually achieved it.
Sure.
So if it's going to be on a routine basis and multiple people are going to use it, then you would want to check which one do you need to use, set it to that so everybody's running on the same stability setting.
Okay. Makes sense. Okay.
One thing, when you turn it off, you do want to hit the log off button, and it just basically kind of shuts the system down.
Mm-hmm.
You don't have to turn this off, though. It can run all the time. It takes very little power when you aren't actually running it. So the other advantage of that is that it's maintaining its temperature if you leave it on.
Does it go into like a save mode or anything like that?
Not really a screensaver or anything.
Right.
It just kind of sits there, but it's fine.
Okay.
Do you usually log in with a certain account? Or?
You can set up to have logins. You don't have to, and it defaults to not.
Okay.
Mm-hmm.
But if you do want to control access, you can go in and set those up, and that gives you
It's
instructions.
detailed in the
Yep,
manual. Okay. Which is on that little key, that red
it's on
key.
there. Yeah. In
I thought
addition,
that was a key, and I was saying, wow, there's no instruction manual. and here it is right here. I just thought it was some kind of, I looked at
A
it,
gift.
it was like the other way around. Like
it's the key to
this.
the instrument.
I'm going, where the heck would you put this? A key. You have to unlock it?
Mm-hmm.
What the heck? But
Yep.
anyway, so it's,
Okay. The manual's-
and is that all that's on there, or is the manual?
It is. So
Okay.
there's this paper right here that if you wanted to use the software,
Mhm.
it tells you where to go to get it.
Ah, okay,
So it's just a download off the internet.
I see.
So that's there. You also have an RS-232 cord if you wanted to connect to a computer with an RS-232, but it also has a USB interface that's already connected in there, just
Okay.
waiting if you want to connect a
Okay.
computer.
Yeah.
And I seriously do not know what this is for. It was in there. I put it together, and I have no idea what its purpose is. So I'll have to find that out. It's
Okay.
some sort of marketing thing that got put in there, and I don't know.
Is
what
it
it's
to
for.
hold the sleeve?
Well, I thought maybe, but it doesn't really work. I mean, if, you
If
put
it lays it down, and okay.
yeah, I mean,
Yeah.
I kind of tried it like that,
Right.
And
Oh,
like,
okay.
I mean, it just.
It doesn't.
Oh well.
That's
I
weird.
don't know what its purpose is. I'll find out and let you know if it's something amazing.
Okay.
Let's see. And you do have one cup here that's empty. If you wanted to check distilled water, you could put distilled water in there and read it. It should read one.
About one.
Yep.
Okay.
Okay.
The other thing you can use this for is you can put activated charcoal in it and then put it in there and it will absorb any kind of volatiles that might be sitting in the chamber.
I see. So, for storage, then, more or less.
Well, no,
when
not
you-
necessarily. It's if you were running a lot of volatiles and you wanted just you were going to move from reading volatiles to reading non-volatiles, and you want to make sure there's not any lingering volatiles in the headspace or the
Okay.
chamber. Stick that in there and shut it and let it sit for about 20 minutes, and then go read your next
A
sample.
little activated carbon.
Yep.
and just a small.
Small
granules.
amounts, yeah, you
Okay.
can just put in there.
The granules. Like,
Yeah.
Okay.
Yep.
Okay.
Okay.
A question in regards to the disposable cartridges.
Uh huh.
Obviously they're disposable, but can people reuse them if it's, let's say, a tablet that we match up and
In here.
yeah.
Well, yeah, you can. I mean, the reason why we say disposable is because of the chance for contamination. So if if you're reading samples again, you're putting something in there what's got some of what you read before, and so the easiest way is just to get rid of them. So you can wash them. Now, one thing, and if it's dry and you feel like you're cleaning it out enough, but typically what we find is that the labor that's required to clean
Yeah,
the
yeah,
cups
yeah.
is more expensive than the cup.
Yeah.
So-
Yeah.
There's that trade-off.
Okay.
All right.
Anything else?
That's it.
So you're doing